Hi everyone, I'm Nirisha, Assistant Professor in the Department of CSIT, working in MLR Institutions of Technology. Today in this lecture, we are going to discuss about parameter passing mechanisms in C language. So coming to the overview, we are going to discuss about one function example and also the parameter passing mechanisms. Those are two, that is call by value and the other one is call by reference, and also the difference between the call by value and call by references. So just a function example. So in this function example, we are going to learn about the GCD of two numbers. We are going to find the GCD of two numbers using functions. So for that, we require the two numbers. So if you are using function concepts, there are some 3 points you may need to remember that we have already discussed in the last class. That is function declaration, a function call, and the function definition. So these are the three things that are mandatory while working with the functions. So coming to the function declaration, this function declaration will tell about the function name and also the what type of inputs you are passing to the function and what kind of output you are expecting from that functions. And coming to the function call, if you are calling a function, so what are the inputs that you are passing to that functions, and if you are getting any return value, so that value should be assigned to some of the variable. And next, coming to the definition, what are the set of instructions that you want to complete a task. So to complete a task, we require some set of instructions. So that set of instructions we are writing in the user-defined functions. So as we discussed earlier, there are two types of functions, predefined and user-defined. Predefined are already defined in the library functions. Coming to this function example, we are finding the GCD of two numbers, which means we are defining, the user is defining to complete that task. Our task is to find the GCD of the two numbers. So for that, this is a header file. And next is a function declaration. Int is the return data type. So the GCD is the name of the function. And the next int comma int. Here we are mentioning the two data types to this function, which are nothing but these two data types are these two values of integer type we are passing as an input to this GCD function. And the output we are getting from the GCD's function is int. So coming to the general concept of the GCD. So I think everyone are aware of this GCD, finding the GCD of two numbers. So coming to the mathematical wise, so how we are finding the GCD? So take an example of 10 and 20. So to this 10 and 20, initially we are finding the factors. So the factors of this 10 are 1, 2, 5 and 10. The factors of 20 are 1, 2, 4, 5, 10 and 20. So coming to the GCD concept, GCD is nothing but the greatest common divisor. So in both the two numbers 10 and 20, the greatest common divisor is 10. This is the greatest number and it is also the common divisor of both the 10 and 20 numbers. So we need to get the answer as the 10. So we need to write some instructions in such a way to complete our task. So for that, initially what we are doing is, we are finding the factors. We are finding the factors from 1 to 10. And in the second number, we are finding the factors from 1 to 20. And the highest factor we are assigning to the result variable. So let's start the program. And then next, inside the main function, we are declaring some three variables, that is A, B and a result variable. A is to store the one number, 2 is to store the second number, and resultant is used to store the GCD of those two numbers. And next, by using printf statement, we are asking to find the two numbers, and by using scanf statement, we are reading those two numbers. And we are calling this function, GCD is my function name, so we are calling that function by using its name. So GCD, and the parameters that I am passing to this GCD function is A and B. We are giving the inputs as A and B to that function. So whenever the compiler encounters this function call, it returns to the function definition. It searches for the function definition and it returns to the function definition. So this is my function definition. The return data type is int. And next, GCD is the name of the function. So A will be copied to this X value and B will be copied to this Y value. So here some two different memory locations will get occurred. So for the main function, memory is different, and for the user-defined function, memory will get allocated is different for its variables. So A and B, somewhere the memory will get allocated, and for X and Y, somewhere the memory will get allocated. So A value will be copied to this X and B value will be copied to this Y. And the next, we are taking some two variables, I and a result. I we are using in the for loops, and a result we are finding, we are storing the GCD value in that res variable. And next, in the first iteration, we are giving I is equals to 1. So in the first iteration, I is equals to 1 and I less than or equals to x. So consider we have read the values as 10 and 20. So A value is 10 and B value is 20. So the A value is copied to x, which means now the x value is equals to 10 and y value is equals to 20. B value is copied to the y. So these are called actual parameters and these are called formal parameters. The parameters that are passed inside the function call, this is a function call, is called actual parameters, and the parameters that we have given in the function definition are called formal parameters. So here in the first iteration, I is equals to 1 and we are checking whether that I is less than or equals to s. So till where we need to iterate this loop? Till that I is less than x and I is less than or equals to y. We need to stop till the number ends. So here, I is equals to 1 and I less than or equals to 10 and we have logical AND operator and I less than or equals to 20. X value is 10 and y value is equals to 20. Here we are using the logical AND operator, which means both the conditions should get satisfied. So I is equals to 1. So 1 less than 10, true. 1 less than 20, true. So both the conditions are true. So the complete expression is true. So if the condition is true inside the for loop, then we are getting inside the for loop. So here inside the for loop, we have written the first statement as if x modulus I. So x modulus I, by using this, what we are finding whether that I is a factor of x or not. And by using this condition, we are finding whether the I is factor of y or not. So that is the thing we are finding, right? So we are finding whether that number is, which is the highest common factor. So which is the highest common divisor. So for that we need to use the modulus operator. If to find the factors, what we need to do, we need to divide that number, divide that x by I. If we get the remainder as 0, then we are telling that I is a factor of that x. So here we are checking whether that I is equals to 1 and I is 1 is factor of 10 or not. So 10 modulus 1 double equals to 0, and one more condition we have, that is 20 modulus 1 double equals to 0. If we divide this 10 by 1, we get the remainder as 0. So that this condition is true. And if we divide this 20 by 1, we get the remainder as 0. So this condition is also true. So both the conditions are true, and here we are using the logical AND operator so that the complete expression, the condition in the F what we have written is completely true. So the condition is true. So that is the reason why we are entering inside this condition, and here we have written I is equals to, we are assigning that I value to the result. I value is equals to 1. So 1 we are assigning to the result variable. So coming to in the second iteration, I value will get incremented by using this I plus plus I will be equals to 2, and 2 less than or equals to 10 and 2 less than or equals to 20. Both the conditions are true. So if the condition is true, then we are finding whether the 2 is factor of that x and y or not. The x and y values are 10 and 20. So by using this conditions, so here 10 modulus 2 double equals to 0 and 10 modulus 2, sorry 20, this is 20, y is 20, so 20 modulus double is equals to 2. If we divide this 10 by 2, we get the remainder as 0, and if we divide this 20 by 2, we get the remainder as 0. So both the conditions are satisfied. So now this 2 we are assigning to the result variable. And coming to the third iteration, in the inside this third iteration, I will be equals to 3, and 3 less than or equals to 10 and 3 less than or equals to 20. So both the conditions are true. So if both the conditions are true, we are checking whether that 3 is a factor of this 10 and 20 or not. So if we divide this 10 modulus 3 double equals to 0. And if we divide this 10 by 3, we get the remainder as 1. So 1 double equals to 0. The condition is false. Hence we are using here logical AND operator. So if one condition is false, no need to check for the other condition, because if the condition is true or false, we will get the complete expression as a false. So here the condition over here when I is equals to 3 is false. So we are not getting inside this F. So if this condition is false, we are coming out of this F. So no more statements in the for loop to execute. So again what it happens, again I value will get incremented. Now I will be equals to 4 in the fourth iteration, and here we are checking whether that 4 is less than or equals to 10, true, and 4 is less than or equals to 20, both the conditions are true. And inside this for loop we have written, we are checking whether this 4 is a factor of this 10 and 20 or not. 4 is a factor of 10, no. If we divide this 10 by 4, we'll get the remainder as a 2. So 2 double equals to 0, the condition is a false. So here one condition is false, so no need to check for the other condition even though it is true or false. So the complete expression for this, if I is equals to 4, is false. And the next is I value will get incremented, I will be equals to 5. And 5 is less than 10 and 5 is less than 20, true. So if the condition is true, then we are checking the condition inside this F. So we are checking whether that 5 is a factor of 10 and 20 or not. Yes, 5 is a factor of 10. If we divide that 5 by 10, we'll get the remainder as 0. And if we divide that 5 by 20, we will get the remainder as 0. So both the conditions are satisfying. So if the condition in the if what we have written is true, so that in the I value is 5. So that 5 value we are assigning to the result variable. And next is I is equals to 6. And we are checking whether 6 is factor of 10 and 20 or not by using this condition. No, 6 is not a factor of 10, not a factor of 20 even. So both the conditions are false. So again I value will get incremented, I will be equals to 7. 7 is not a factor of 10 and 20. So I will get incremented, it will be 8. And 8 is also not a factor of 10 and 20. And I gets incremented, I will be equals to 9. So 9 is also not a factor of 10 and 20. And next I will get incremented, I will be equals to 10. We are checking that 10 is a factor of 10 and 20 or not. Yes, 10 is a factor of 10. If we divide that 10 by 10, we get the remainder as 0 by using this condition. And if we divide that 10 by 20, if we divide that 20 by 10, we'll get the remainder as a 0 in the second condition. So here also both the conditions get satisfied. So if both the conditions get satisfied, the I value is 10, the 10 value we are assigning to the result variable. And next I value will get incremented, I value will be equals to 11. And here the condition get false. So 11 less than or equals to 10, it is false. Here we are using the logical AND operation, both the conditions should get satisfied. So that is the reason why we are coming out of this for loop. And the next we are returning the RES value. In the RES value, we have the GCD of those two numbers. So the GCD of two numbers is 10. So the 10 value will be returned to the main function over here. So the value of this GCD A comma B is equals to 10. So this 10 value we are assigning to the RES variable. It is an equals to operator. Whatever the value comes over here, that we are assigning to the RES variable by using an equals to operator. And by using this printf statement, we are printing GCD of given two numbers is equals to what the RES variable will have, that 10 value will be printed over here. So this is the test cases. Enter two numbers. To find the GCD, we are giving the first number as 10 and second number as 20, and the GCD of the two numbers is 10. So in this way, the functions are going to execute. So we need to remember some 3 points, that is about functions, that is the function declaration, function call, and the function definition. And also we need to know about some 2 points about the calling functions and the called function. So here main is called the calling function. This function is calling this GCD function. So this is main is called as the calling function, and this GCD is called as the called functions. And next is a parameter passing mechanisms. So parameters are nothing but what are the inputs that you are passing to the functions. So we are going to discuss about parameter passing in C. When a function get executed in the program, the execution control is transferred from calling function to the called function and executes function definition and finally comes back to the calling function. Just now we have discussed about this called functions and calling function. Whenever the function is called, it goes to the function definition. And again, after the execution completes in the function definition, again it returns back to the main function, that is calling function. So when the execution control is transferred from calling function to the call function, it may carry one or more number of data values. So those data values are nothing but the parameters. In the previous example, we have called the GCD function, and that GCD inside that GCD function, we have passed two values, that is A and B in the function call. So that A and B are nothing but the parameters. So parameters are the data values that are passed from calling function to the called function. So in C, there are two types of parameters. One is actual parameter and the other one is the formal parameters. So actual parameters are the parameters that are specified in the calling function. And the formal parameters are declared at the called function. When the function gets executed, the copy of the actual parameters values are copied into the formal parameters. So coming to the previous example, so these are called the actual parameters and these are called the formal parameters. Based on this actual and formal parameters definition. So in C programming language, there are two methods to pass parameters from calling function to the called function. They are as follows. One is the call by value and other one is the call by references. In the call by value parameter passing method, the copy of actual parameter values are copied to the formal parameters and formal parameters are used in the called function. And here the most important point to be noted is the changes made on the formal parameters does not affect the values of the actual parameters. So what are the changes you are making in the user defined functions that are not reflected back in the main function by using this call by value mechanism? So that means after execution of the control come back to the calling function, the actual parameter values remains same. So one of the example of this a call by value. Here we are finding the swapping of two numbers. We are doing the operation like we are swapping the two numbers. So for that, this is a function declaration and this is a function call and this is a function definition. So here in the function declaration, void is my return data type and the swap is my function name, and here the values that I am passing is two integer values. So that I am taking the I'm declaring the two variables, that is a and b, and I am initializing the values of that a and b, and one more printf statement, that is I am printing the values of a and b before swapping. And next we are calling a function that is a and b, so the control will shift to the definition. So the a will be copied to this variable and b will be copied to this variable, and one temporary variable we are using, as we know the swapping logic, the a we are assigning to the temporary variable and b we are assigning to the a, and the temporary variable whatever the value we have that we are assigning to the b. And again after completion of these three statements, the control will return back to the main function. And next we have one more printf statement, that is after swap a value and b value, we are printing those two values. So coming to the test cases, before swap a is equals to 10 and 20, as we declared that initialized a and b values as 10 and 20, and after swap also the a and b value is 10 and 20. So this is the thing that is happening in the call by value. Whatever the changes that you are making in the user defined functions are not reflected back in the calling function, that is in the main function. The actual parameters remains same. So the actual parameter value is 10 and 20, and after execution of the function also the actual parameters values are 10 and 20. So to overcome this problem, we have another mechanism, that is call by a reference. So in this call by reference method, the memory location address of the actual parameters is copied to the formal parameters. So this address is used to access the memory locations of the actual parameters in the called function. So in this method, the parameter passing, the formal parameters must be using the pointer variables. So we are using the formal parameters as a pointer variables because we are, instead of passing the values, we are passing the addresses. So the values, to find the values that are present in the addresses, we are using the pointer variables. So that means in call by reference parameter passing methods, the address of the actual parameter is passed to the called function and is received by the formal parameters, that is pointers. So whenever we use formal parameters in the called function, they directly access the memory locations of actual parameters. So that is the reason why the changes made in the formal parameters affect the values of the actual parameters. So whatever the changes we have made in the called function are affected back in the calling function parameters. So that was not done in the call by value. So coming to the example of a call by a reference. So the same example we are taking, that is swapping of two numbers. The return data type we are using is void and swap is my function name, and here the integer data type we are mentioning, and we have one star followed by the data type, which means we are telling to the compiler that we are using an pointer variables. And here we are taking a and b values and same values 10 and 20, and we are printing the a and b values before swapping, and here we are calling the function, And the parameters that we are passing to the function call is address of A and address of B. Instead of passing the 10 and 20, we are passing the address of A and address of 20. As soon as we declare the variables, what it happens, for A, some memory will get allocated, 4 bytes of memory, and for B, some 4 bytes of memory will get allocated. So consider some 100 location, it got the memory allocated, and for B, some 200 location, the memory got allocated. And the 10 value will be stored in this A and 20 value will be stored in this B. So whenever we are calling this swap function, so here the address of A is 100 and address of B is 200. So the addresses are passed into this function call. So whenever the function call happens, it returns to the function definition, and here the address is copied to this A and address of B is copied to this B. So here we are using the pointer variables. So if the A value, so for A value, some separate memory got allocated, that is a pointer variable, and B value separate memory got allocated. This is a user defined function. The memory got allocated for A and B, and this is a main function. The variables got memory allocated in main function. So A is a pointer variable, so consider some 1000 address locations. For A got memory address, and for 2000 address location, the B got memory address. And in this A, we are passing address of A. Address of A is 100. So the 100 will be the value that is assigned in this A variable, and this address of B is copied to this B variable, so that is 200, which means the address of B is 200. The 200 value is being copied in the B variable, and here the A and B values are the pointer variables because we are using a star over here. So by using this star, we'll get the values that is present inside the address location. So here, so coming to this int temp, one temporary variable. For this temporary variable, memory got allocated, and to this temporary variable, we are assigning the star E. Star E. A is in the A value, we have the 100 value. That is nothing but the memory of that, this E. Memory of the value that is present inside this E. So by using this star, what we get? See, this is a star A, consider. So A value is 100. So before this 100, we have the star. So by using this star, we'll get the value that is present in the 100 location. So the value that is present in the 100 location is 10. So the 10 value will be stored in this temporary variable. And next, star B, that is nothing but the B value that we have is 200. So 200 we have, before that address, before that value, we have one star, which means we'll get the value that is present in the 200 address location. The value that is present in the 200 address location is 20. So that 20 we are assigning to the star E, which means we are assigning to the star of this 100. So this 20 we are assigning in the address of this 100. So now this 10 will be replaced by using 20 by this line. And the next temp value is 10. So the temp value we are assigning, the temp value is 10. So the 10 value we are assigning in the address of this B. So here the B value is 200. So this 200 value will be assigned, so this 10 value will be replaced in the place of this 20. So in this way, whatever the changes we have done in the user defined function, that are got reflected back in the main function. Why? Because instead of passing the values, we are passing the addresses. Instead of passing values, we are passing the addresses. So after completion of these 3 statements, it will return back to the main function, and we have one printf statement that is printing this A and B values. So here the A value is 20 and B value is equals to 10. So if we find the test cases, before swapping we get the A and B values as 10 and 20, and after swapping we get the values of A and B as 20 and 10. So the drawback of this call by value is the changes whatever we are making in the user defined functions are not reflected back in the main function. But coming to the call by references, the changes what you are making in the user defined functions are reflected back in the main function, which is nothing but a calling function. And swap is called the called function. And one more example of this call by value. So In this example, we are just adding one number to the given input. So for that, the function name we are taking it as a void. Function name we are taking it as a add, return data type is as a void, and the data type that we are passing to this function is integer. And inside the main function we are taking in variable, we are asking to enter that number, and by using this scanf statement we are reading that particular number. And the given number before adding, the n value we are printing, and next we are calling that add function. And this is the actual parameter and this is the formal parameter. The n will be copied to this x. So in this, for n, memory will get allocated, consider it as 100. And for x, some memory will get allocated, consider it as some 200. So n value is the value that we have read, that is 5. So the 5 value will be copied to x. So here the different memory allocations are done for n and x, that is for actual and formal parameters. So whenever we call this function call, it will come over here and that n value will be copied here, and x is equals to x plus 10. X value is 5. So to this 5 we are adding 10. So it will get it as, will get the output, will get the x value as 15. And again it will return back to the main function. And here by using this printf statement, we are printing the n. And here the n value is 5. So that is the reason why whatever the changes, the different memory allocations are done for actual parameters and formal parameters. That is the reason why whatever the changes we are making in the user-defined functions are not getting reflected back in the main function. So if you observe the test cases, we are giving some number as 5, and before adding is 5 and after adding is also a 5. So coming to the call by references. So same example program, we are adding some 10 to that given number. So here we are same thing. Function name is add, return data type is void, and here we are using a pointer concept. That is the reason why we are using star after that data type in the parameters. And n, declaring n, we are asking to enter n. By using scanf statement, we are reading that n, and by using this printf statement before adding. So before adding, the value of n is 5. So that 5 will get printed, and the next we are calling this function. So add function, but instead of passing that n value, in the previous example, we have passed the n value. Now we are passing the address of n. So to this n, if you take the last example, so to this n, the n value is 5, and the address we have allocated, to store that value is, consider it some 100 location. So we are passing this 100. So to this add function, instead of passing that 5, we are passing this 100 address. So 100. So that 100 will be copied to this x. So in this x, we have a value. What we have value? What is the address of n? Address of n is 100. So that 100 is copied to this x. So as we discussed, it is a pointer variable. Pointer will hold the address of the another variable. So this x is a pointer variable. So pointer is holding the address of another variable. Address of another variable is 100. That 100 is we are storing in this x. And then next, if you see here, star x, which means the value, that is by using this x value is 100. So by using this star, what they will get the value that is present in the 100 location. So the value that is present in the 100 location is 5. So 5 plus, here we have some 10. So that is equals to 15. So this 15 where we are assigning to the star x, which means the x value is 100. So before this x we have a star. So this 15 will be assigned in this 100. Sorry, the 15 will be assigned in that 100 address location. So in this address location, directly the value, whatever the changes we have made, that will get reflected. So 50 will be stored in the 100 address location. So here, whatever the changes we have made by passing the addresses will get reflected back in the calling function. So here the given number after adding is n. So in the n value we have 15. So that 15 will get printed. So here the memory is going to be shared, which means whatever the actual parameter address we have, that address itself we are passing to the formal parameters, and we can hold that address, we can catch that, like we can store that address by using a pointer variables. Pointers will store the addresses of the another variable. So by using this address we won't get anything. So by using that star we'll get the values that is present inside the address. So that is the reason why we are using this Star is nothing but a dereference operator, and this is nothing but a referencing operator. Here we are passing the references, that means addresses, and by using the star we'll get the value that is present inside that address location, which is nothing but dereferencing operator. So this is about call by value and call by references. And coming to the differences, so the function is called by passing the parameters values in the call by value, and the function is invoked or called by passing the parameter references, which is nothing but the memory location of the variables in the call by references. The changes made on the formal parameters does not affect the values of the actual parameters. The changes made on the formal parameters affect on the actual parameters in the call by references. Actual and formal parameters will be created in different memory locations in the call by value. Actual and formal parameters will share the same memory locations in the call by reference. Here no pointer concept are used in the call by value. Pointers are used in the call by references. Thank you.